Okay, so I will talk about Binary Builder, which is a Julia package to build binary programs, especially libraries or executables. Okay. So first of all, if you want to install the package, you can do, as usual, you can enter the package manager mode in the REPL, in the Julia REPL, and do binary builder. Hello. Okay, so after you install the package, you can use it with using binary builder and starts pre-compiling something as usual. Can you see the screen? It's clear enough, it's large enough. Oh, okay, good, thanks. Okay, so now we can do something. So binary builder is this package to, again, build libraries and executables. The nice thing about binary builder is that we can build for a lot of platforms at the same time. Thanks. You can see here the list of all supported platforms with a supported platforms command function, and you see we have plenty of Linux-based platforms, macOS, FreeBSD, and Windows 32 bits and 64 bits. So what binary builder provides is a shell, basically. It's an environment which is based on Alpine Linux, and you can enter in in environment, for example, in this way: binary builder.run shell, and then one of these platforms that you can see here. So, for example, here I'm entering the macOS environment. So it is going to create the environment for you, and you will be dropped into this shell. And yes, here you have, for example, CC is the cross compiler for macOS. In this case, for macOS and FreeBSD, we use Clang. So here CC is complaining that there is no input file. And we also have C++ for the C++ cross compiler, and gfortran for the Fortran compiler. And that's it. And then you also have a lot of other tools available in the environment. But this is just to show what's the basic environment. As you can see, you have this shell. For example, if you run a uname, you see the target actually. So you see Darwin. in this case, because Darwin is like the uname of the platform for which we want to compile in this case. But yes, this is actually an Alpine Linux distribution modified by Elliot Saba and Ken Fisher to include all the tools that we want to use for the cross compilation. Then we can leave this environment and start the wizard. Yes. So the function is BinaryBuilder.run_wizard, and here it will start the wizard that will guide you through the cross compilation of some software that you want to cross compile. So the first question is what platform you want to target. So for example, here I want to build for all the supported platforms that are the ones that we have seen here. But you can also choose, for example, select only an operating system. So for example, you want to build only for Linux and FreeBSD, for example, or you want to choose each specific platform from this list. But yes, I want to build for all supported platforms. And now it will ask me what I want to build. So for example, now I want to build libsodium, which is a popular I will show my browser. Okay, so libsodium is a popular library for cryptography. So the wizard is asking whether to provide a URL, which can be either a Git repository or a compressed archive. So in this case, I want to use a compressed archive. So the release tarball, if there is something here. Yes, so you go, for example, for libsodium, you Google libsodium and you go to the list of releases on the GitHub page, and you get should be this one. You get the address of the URL of the tarball that you want to build. So you go back to the terminal and you paste here, yes, the URL. It's downloading it. And then it asks if you want additional sources. In this case, I don't want additional sources, so I can say no, which is also the default choice. You can see N here is capital, so this is the default choice. I can just press enter. So do you require any binary dependency? Also in this case, I don't want anything else, so I can just press no and go home. So now it asks me the name of this project. I want to call it libsodium. Yes. Version number, what was the version number? It was 1.0.18. It's also asking me if I want to customize the set of compilers, because actually this environment provides you GCC and LLVM as compilers if you want to compile C, C++, and Fortran libraries and programs. But you can also choose to do to build Rust and Go programs if you want. So in this case, if I choose yes, I can select, for example, the cross compilers tools also for Rust and Go. But here libsodium should be, I think it's C or C++. Yeah, it's mostly C library. So I can just use the default set of compilers, which is this for C, C++, and Fortran. So I can go on and press enter. And then you start, you enter again in the shell environment that we have seen before. And you see that the wizard is telling you that you are building for Linux x86 64 using glibc as a C library. And it's also giving you some suggestions about what you can do in the environment. And in particular, it's also inspecting the content of the directory where you're in, and it's telling you that if you go into the libsodium directory, there is a file called configure, which is a standard file generated by the GNU autoconf build system, which you can use to build this library. So we follow the suggestions to run this command. So you can just copy and paste from the terminal, from the hint given by the wizard, which is also telling us that probably after running configure with all this set of arguments, we should run make and make install. So we run the configure script, and it finished successfully. So we can do make. Actually, to make the compilation a bit faster, we can use parallel compilation. So we can do make -j, and proc is a variable provided by BinaryBuilder, which keeps the number of available processes that we can use for the build. So it's building now. Okay, we see no errors, so probably it was successful. We can install with make install, and that's it. We can just exit pressing Ctrl D. Okay, so this is the build script so far. These are the commands that we run. We entered the libsodium directory. We run configure, make, and make install. We're happy with this build script, so we can press enter because we don't want to edit. And so now what it's doing is to inspect the content of the destination where the library was installed, to check that everything is correct or as it expected. We also have a check on the license and the presence of the license file, which is good. And so now the wizard has found some so-called products. In particular, it found this lib/libsodium.so, which is a shared library, which is actually what we want to provide. And it is asking me for a name for this variable. We will see later what is this. So we'll call to this product just libsodium, press enter. And now the wizard will try to build for all other platforms. So what it's doing is to reload a different set of cross compilers for each different platform, and we'll repeat again the build script that we have generated so far to check if everything is fine, if the build process is going to produce the same product as before, which is the libsodium shared library. And yeah, we will see how it goes. Hopefully we should have no problems with this library. So it already finished and it's analyzing the result. It's okay. So the compilation for this platform was successful, and we can press enter to go on with the next one, which is 64-bit ARM Linux. So the good point of this framework is that with a single build script you can generate the tarbles for a lot of different platforms. So you don't need to have like 13 different machines with 13 different operating systems to build the libraries, but you can just use your own machine to build for all of them. So also Arch Linux was Arc64 Linux was successful. Now we can go on to build the rest of the platforms. So yes, I was saying that we can build using a single environment for all these different platforms. The advantage is that we can use just a single environment. The drawback is that what we do is to do cross compilation, which in most cases is actually fine. In very few cases it's very hard. But you know, it's also fun to have problems and to fix them. So compilation for this platform was successful, and now we are going on with the next one. We should be, I think, 32-bit Linux. So it's going on. So yes, consider also these different platforms that we support have also different architectures. For example, this one is 32-bit i686. This is ARM. This is PowerPC. So doing a native build for this platform will literally require different machines. So it's not just something that you can do in dual boot, that you can have multiple operating systems on the same machine, but you really need different machines. And instead here we are just building this library for all these different platforms. So actually we support also some Linux platforms using Muzzle as a C library, so not just the GNU C library like this one, but also Muzzle, which is actually the C library used by Alpine Linux, which is the environment where we work. So it's good also to be able to target this kind of platforms. So what you see here, this string i686 Linux GNU is called the triplet of the platform. It's called triplet because it's compounded by 3 parts. So here you have the architecture, the operating system, and the C library, for example, for this platform. So maybe, I don't know if I can scroll up. No, it's gone. But yeah, when you run the function supported platform, you see the list of all the platforms that we support with BinaryBuilder, but you can also get this triplet, which is sometimes useful when you want to enter an environment only for one of these platforms. So remember, this is the triplet, this one. So So it's going on, it's all successful. I think we are almost done with the Linux platforms. Yes, now we are going to macOS. So we are building the library for this platform, which is basically macOS. So in this triplet here we have the architecture, Apple for macOS, and Darwin 14 is the kernel used by the operating system. So the nice thing about BinaryBuilder is that what it produces in the end is a set of tarbals of compressed archives, which contain the library, the executable, probably also the header file if you are building a C++ library, and so on. But this is nothing specific to Julia. So this framework has been written in Julia. Now we are in a Julia session to do this, but the product is literally independent from Julia. So the nice thing is that you can reuse this to build libraries for something else that you can just install in your system if you really need to. So okay, now macOS was successful. We are building for FreeBSD, which is an interesting platforms. Usually this is the platforms that is the most commonly failing because no one cares about this platform basically. So when something is successful for the compilation of a library is successful for FreeBSD, we can be quite confident that it will work for any other platform. So it's a good test bed for cross compilation. Yes, so by default, I think I already said this, by default we use GCC to build for Linux and Windows. Instead, for FreeBSD and macOS we use the LLVM. But in each environment both compilers are available, and if you need to, you can just decide to switch to one or to another, the other one. This build is a bit slow now. Okay, so this one was successful too, and I think now it's building the last one because we have built for 64-bit Windows already before. So this is Windows. It's the 32 platform and using the MingW 32 cross compiler, which is basically I think it's like a fork of GCC targeting only Windows. So it provides also all the libraries, system libraries for Windows. Okay, so we are done. This is the build script, it's successful, and we can go on with the deployment. So we have 3 different choices. We can't just print to standard output the build script or write it to a local file or open a pull request for Yggdrasil. So Yggdrasil is this repo, you can still see the you can hopefully still can see the browser. So Yggdrasil is this repository on GitHub. Is the collection of all the builders that we are producing. It takes the name. The terminal is cut apparently. No, I think it should be fine. No, it's what you see. The last line is a print to standard output. Ah, okay, yes, it's the last one. Yeah, also for me. So yes, Yggdrasil is the name of the mythological tree in the Norrøn, I think, mythology, which is represented here, and it's the collection of all the builders. So going back to the wizard here, I don't want to open a pull request because actually the builder is already in the Yggdrasil repository. I just want to print to standard output. So the builder is just this one, but actually I can show you here in the repository is better. So Lipsodium, it's here. Okay, so this is what the wizard has written to the standard output. It's this script, it's a Julia script, which defines the name of the builder, the version, the source that we have provided. And this is the build script that we have used. Well, here it's slightly different, but it's almost the same. So the list of all the platforms that we have targeted. In this case, we wanted to build for all the supported platforms. And the product that we have found, which is a library, a shared library. So here you'll see a library product whose first argument is the name of the file, the base name actually of the file. So without the extension, the .so, because the extension will be different for each operating system. So usually it's SO for Linux and FreeBSD, .dylib for macOS, and .dll for Windows. And this one, the second argument of the library product, instead it's the name of the variable that I will show you in a sec. Dependencies, there are no dependencies in this case because Lipsodium can just be built using the standard C library and nothing else. And build torbals is just the final function that puts everything together, all the variables that we have defined here. So you feed this function with all these variables and you just build the torbals as the function says. So okay, so what we have done actually, so if you open a pull request here on Yggdrasil, so if you go here, there are some pull requests, and for example, maybe I will show you a closed one. So for example, there was this libdiff library. So we have a very sophisticated CI system which builds. So actually you don't have to build locally. Well, you can use the wizard to build locally if you want. I remember that so far BinaryBuilder only works on Linux and macOS, so it doesn't work for Windows, unfortunately, so far. So if you open a pull request here on Yggdrasil, it will be built for all these platforms on our machines. And if everything is fine, there is also the registration step. So this is more interesting for the Julia side, on the Julia side. Because what we do is to generate this is basically just a Julia package. It's called JLL. It's a joke on DLL on Linux, on Windows. It's the Julia dynamic library, kind of. But this is nothing else than a regular Julia library, which has an artifacts.toml file, which will download the build library for each operating system. So in this case, we have the specification of the architecture, the C library, and the operating system. And for this environment, for this platform, then you can download this tarball, which has this SHA-256 hash. So the tarballs are built and uploaded here. So if you go to the list of releases of the JLL package, here in the list of releases we have uploaded automatically. This is done automatically by the CI system, which is based on Azure pipelines. So they're automatically uploaded here. So if you want, you can just download one of them. For example, my platform is this one, so I can just download. Yeah, and inside there will be the content of there is the library, the header files, and the license file, and that's it. So these tarballs, again, they are completely independent from Julia. They can be used. They can be used to do anything, to be installed if you want on any platform, on any of these platforms. So on the Julia side, what we do is that then, if you want, you can go to the terminal. Sorry. You can go to the terminal and install this libdiff just in this way, as a regular Julia package. And then you do libdiff JLL, and it's opening also the library. So if I use the variable libdiff, it has the path to it's the name of the shared library, but you can see here that the variable the library has been opened using basically libdl open. So DL open is the standard name for the NC to open a shared library. So this has been opened, and this is the address in memory of the handle of the library. So now you can just do a ccall in Julia to a function in this library. And so no, sorry, now I don't know the name of the functions provided by this library, but for example it's foo, I don't know, libdiff, and yeah, the rest of the syntax of the ccall to call the function foo, whatever, in this libdiff library. So most of the users actually don't need to know anything about these JLL libraries. This is more interesting for Julia developers that want to wrap a binary library. So what they can do in their library, in their Julia packages, is to depend to the dependencies of of the Julia package, add, for example, libdiff in this case, and then they don't need to ask to the users to install a libdiff on their own, but this will be automatically installed, and the library will be automatically downloaded, as we have seen here. And yeah, it's really convenient for the users. So I know in some cases this is an inconvenience sometimes for the users, especially on Linux, where the libraries are very easy to, most of the libraries are easy to install. But the advantage of using this system to provide the libraries is, first, is that the developers can be sure that the library will be available for all the users. So it's not that okay, on Linux the users are fine, but on macOS maybe they can use a homebrew, and on Windows they cannot use my library. No, so in this case you're sure that the library will work always for all the platforms. And also, actually, one good thing is that since you are going to provide to the users the library, you also know the version of the library, so you can focus your Julia wrapper on a single version of this library. You don't have to, for example, support multiple different versions of the library, of the binary library. So sometimes this is a good thing, when you can be pretty sure that it's going to work on a single version, or a specific version. So there is a question. So how would one go about building multiple libraries for the same platform? Okay, so Scott is asking how to generate multiple versions, yes, of the same library. For example, he has in mind PCRE2, but using 8, 16 or 32 bits. So if it is not possible, I don't know, if it is not possible to have a single library, a single Julia JLL package with all the different versions, the ideal would be to have 3 different builders. So in Yggdrasil, actually we have some examples. No, it's in Yggdrasil. So it's not exactly what Scott is asking, but for example for OpenBLAS we have, well, no, it's kind of the same thing, because for example here we have the 32-bit version of OpenBLAS, but also the 64-bit version, which is the default, and also in different versions of the library. So here we have, for example, 0.3.5, 0.7, 0.9, but for the 32-bit version we are only supporting the 0.3.9 version. So yes, you can look, for example, what we do in OpenBLAS. We have a different build topple scripts for each version. So if there is the possibility to reuse some code, what we are doing here in OpenBLAS is to have a common.jl file, which has, yes, a single script basically. So this is a sophisticated example, but it's kind of useful because we can have, yes, a single script which is targeting all the different versions that we want to build. So you can probably take inspiration from OpenBLAS to see what we are doing here, to provide the different versions. So 32, 64, and actually this one, if I remember correctly, we are building for many threads, because probably by default OpenBLAS, this is the, let's say, default version of OpenBLAS, So this is targeting, I don't know, maybe 32 threads. Instead, this one is using a larger number of threads. And yes, I hope that I answered your question. So honestly, I think it's a bit inconvenient that we have different packages with different names, but so far this is the best that we can do. So I would like to have like the possibility to specify only I need OpenBLAS in different flavors, or the user can choose different flavors. Instead, here we are literally providing different packages with different names. So we have OpenBLAS 32, OpenBLAS, or OpenBLAS I core count. But yeah, so far it's mostly working, so it's okay, but maybe we will see in the future if we can do something better. So what I wanted to show now is that sometimes compilation is not successful. And this is, I think, the most fun part. So for example, now in Yggdrasil there is this pull request to build Ghost script. But it's failing. So it's failing. So what do we do here in the CI service that we are using is to build using a different job for each platform, so we can easily see which are the platforms that are passing and the platforms that are failing, which also actually usually gives us an idea of what's the problem. And this is, for example, the case here. So here is passing for 32 and 64 bits Linux with a glibc library and the same architecture, same operating system, but with the Muzzle C library. So usually this is an indication that cross compilation is failing, because actually for these 4 platforms we can do a native compilation, because this Alpine Linux that Elliot and Kino have built, the Alpine environment that we're using for the cross compilation, can actually do native compilations for these 4 platforms. Because basically in this environment there are both the Muzzle and GNU C library, and so when you try to run an executable with either the GNU C library or the Muzzle library, it will automatically find the corresponding C library in the environment. And we also have in this environment the possibility to run both 32 and 64 bits executables for this platform, for the x86 platform. So yes, when I see failures like this, I'm pretty sure that something is going wrong with cross compilation. So for example, we can look to the log of this build. I hope that you can see. Okay, sorry, there was another question from Scott. Okay, yes, actually, if you can build different products, so Scott is asking if you can, that with the old system, he was producing probably multiple products. Yes, it's possible to produce multiple products. So if you can have a single JLL package providing all the different products. This will be the ideal solution, because in this way you don't have to produce multiple JLL packages. Definitely, if you can produce multiple products, it's fine. Yeah, that should be fine. So yes, here this ghost script build for I think it was 64-bit ARM. It's failing during configure, during running configure, and it's failing it's failing. Yes. So it's trying to run SC compiled program and it's failing. So this is the most annoying case, of course, because again this is a cross compilation environment. So if we cannot cross compile, it's a problem. So actually what I want to do here is to try to compile locally. So let me go here. So I can check out the ghost script pull request. So in the terminal, so this is one nice thing that we can do. So I enter the ghost script directory. So actually the build torvalds.jl is a script that you can run in this way. No, sorry. I wanted to show you the help first. So this is a script that you can run by doing a Julia and the name of the script. And with the help argument, you can see the usage, which is of course useful to know what to do. So you have a set of different options. So there is only one argument. The argument is the list of targets, which is the list of triplets basically. And so now I can show you. So this was the list of supported platforms, but with a triplet function you can get the corresponding triplets. So the triplet corresponding to this platform is this one, and so on. So I use this function, this command very often to get the triplet for the platform that I want to build for, because this is, for example, important in this case, because you can build, you can run the build torvalds.jl script only for one or some platforms. Without any arguments, it will build for all the possible or all the supported platforms. Well, for all the platforms specified in the script, in the build torvalds.jl script. So you have some useful options here. Verbose, it will show to the standard output a verbose log of what is doing. This is for me the most useful argument option, the -- debug, because this will drop you into an interactive shell, and I will show you in a second. So instead I will mention this briefly. This deploy option is very useful if you want to, if you don't want to send the build script to Yggdrasil, but instead you want to generate the JLL package on your own. You can deploy to your own repo. So keep in mind that if you don't want to go through Yggdrasil, you can deploy to your own repo. And this, for example, is useful if you want to test the library on your own before opening a pull request to Yggdrasil. Yeah, so this is, sometimes this can be useful. So I showed you that you can run the wizard to produce the build script, but actually what I do most of the time is to just use an existing build script and modify it to build for a different library, and then I can use this command that I'm going to show you to build to try the build to try the build script and see if it's going to work. So here actually we already have a build that is failing, and we want to see we want to see why it's failing. So it was failing, for example, for this platform. So I go here to the 64-bit ARM Linux platform, and I do Julia, color yes, because I want to see the colors, build torvalds.jl, and I pass as argument this platform, and then I need also the verbose because I want to see some output, and also the --debug. So this is a command that I run all the time. Julia, color yes, build torvalds.jl, and then verbose and debug. So now I'm going to run the GhostScript build script for this platform, and it will probably fail, and I will try to understand why it's failing. It's downloading something. I don't know what. Yes, so if the build is going to fail, the --debug option will drop us into the interactive shell that we have seen before. So one inconvenience of using this workflow is that while the wizard is going to record all the commands that you run during the wizard, this is not recording anything, so you must remember all the changes that you do while you are inside here. So what I do is to like when I run a command and I see that it's working, I immediately copy here in the build script to remember what I did. So the command that was failing was again this configure. It's saying if you meant to cross compile, use host, which is fun because we are actually running this command, so the host argument is passed. So why it's failing? So building these libraries, if something is works flawless, it's great. It's very simple, like ellipsoiding was very easy. But when something is failing, you have to use a lot of time to understand why it's failing, and you have to read carefully what's going on. Okay, so apparently what it's doing, this build script, is to recursively call some other build script somewhere else. Yes, so for example, the root I can show you maybe what is the root of this environment. So if you go to the root, you will see, maybe the workspace is more interesting. Yes. So destir is the content of destir, of this workspace slash destir, is what will go into the tarball. So what Binary Builder does is, after the compilation, it will enter this destir directory, and whatever is inside of this directory, it will put into the tarball. So this really is the content of the final tarball. Actually, Binary Builder, it will remove from this destir directory whatever it's in one of the dependencies. For example, in this ghost script build script, we are using as dependency libtiff. So in this case, here, if you go to destir and lib, we will find the libtiff binary shared library, but also all the dependencies of libtiff, because libtiff depends also on libjpeg and libz and libz standard. So what we'll do, Binary Builder, after a successful compilation, is to remove all these files that were already in one of the dependencies, so that in the end, in the ghost script tarball, there will be only the files for ghost script and not all the files that are here. So it's very smart, this system, because it removes duplication. So yes, in the workspace there is, so sourcedir. Yes, so sourcedir is where the sources are installed, and destir is where the dependencies are installed, and also again the final product of the compilation. So it's important, when we do this build, it's important to pass this argument, this option to configure, because prefix is where the library will be installed. In fact, we can see the value of this variable, which is in fact the workspace destir, and so again it will be installed in this directory. Instead, the source of the library is installed in workspace slash sourcedir. So it's in here, we can enter. So when configure the GNU autoconf configure fails, well, actually also if it is successful, it generates this file called config.log. So for example, we can do less config.log to see the content of this file, but actually there is one trick that I use all the time. So this build is actually run in a subdirectory of the build tarballs.jl script, where basically we are. So it creates a build directory. If you enter, there will be another subdirectory corresponding to the platform that you are targeting. And then if you enter here, there is a directory with a random name, just to avoid overwriting all the time the same directory. And then we see again basically the content of the workspace. So basically the content of this directory is the workspace, is what you see here in the workspace. So now we want to enter the sourcedir ghost script, and I can open the file config.log directly in my editor, which I think it's a very convenient thing to do, because you can more easily work rather than from within the interactive shell. Also because unfortunately Emacs is not available, and I am an Emacs user. So we were seeing that there was a recursive call. Yes, so the configure here is stopping after calling the configure script. And sorry, 1 second. Yes, so we were seeing that it was failing configure, yes. It was failing in this directory that I don't have. So probably this one was created automatically by the build system and also removed automatically, so I don't see it anymore. Because what I would have done here was would be to enter this directory to see the content of the config.log file to see what's going on. I'm doing this now, so I really don't know what's happening. So, and literally this is what I do. It's to spend a lot of time thinking about what to do and how to debug what's happening, what's going wrong. So this is very annoying because I can't see why it thinks that I'm not using this argument, because I'm using it here, but probably this is not forwarded to the configure script, to this auxiliary configure script, sorry. So yeah, what I will do now is to Google cross-compile ghost script. You're probably not seeing the screen, the browser. Okay, so I googled cross-compile ghost script and I got to this page. Cross-compiling. Okay, cross-compiling is not fully supported by the configure script. This is super annoying. And this is exactly the reason why this was failing as I thought. This was failing for, well, it was successful only for these platforms, because this is the platforms. These 4 green platforms are those for which we can do the native compilation. Yeah. So the suggestion here is to run configure. Okay. Well, I think I will take some time, not now, to understand how to do this. But yeah, maybe I can anyway show you something in the terminal here. So the CC, so okay, this is independent from this particular cross compilation. So the CC environment variable holds the name of the cross compiler that we want to use. So CC is actually a symbolic link to the cross compiler that we want to use. In this case, yes, we can do this. Yeah, so CC is actually a symlink to the GNU cross compiler. It's GCC. But in here there is also Clang. So what you can do sometimes, if you want to use a different compiler, because for some reason you want to build using Clang, if the build system looks to the CC environment variable to determine which is the C compiler, you can do export CC equal to Clang, and then when you when the build system, the environment variable CC will be used, the command Clang will be used instead of the default, which is just CC. So yeah, this is one common suggestion, that you can just change the cross compiler in this way by changing the changing here the variable. And the same also for example, CXX is the name of the C++ cross compiler, which by default is called C++, and it points to G++, which is the GCC compiler for C++. But I think that you can use, yes, Clang ++ if you want to build. So for example, you can do export equal to Clang ++ if you want to build for a C++ program using Clang. Some other interesting tricks. Well, you can find some useful instructions in the BinaryBuilder documentation. So if you click here, you can go to the documentation. So here there are some tips for building the packages. Yes, so for example, this is what you usually have to do when you build for autoconf based library. So hopefully you only need to run these commands, but again, if you use the wizard, it will tell you what to do. If you are using cmake, this is the command that you have to use. So like in the configure case, you have to specify the prefix, so the destination where the library will be installed. This is also very important, the toolchain file. I can show you here. So cmake target toolchain file. So this is a file which specifies the name of the operating system, the architecture of the target that we want to build for, the sysroot, the value of the install prefix. We're just using the value of the environment variable prefix, and then we are specifying the C cross compiler, the C++ cross compiler. So these files, these cmake toolchain files are already available in the environment, and you can just, again here in the cmake call, you can just pass this argument to specify which is the toolchain file that you want to use, so that you can just get all these settings for free. You don't have to specify all of them manually. Another often useful argument to pass to CMake is this one, the CMake build type equal to release. It will build a more efficient library or executable, so probably without the debug symbols and using O2 or O3 as optimizations, depending on the specific build system used by the library. And if you want, here you can see some examples of builders that are using this CMake based build system. We also support Meson, which is another nice build system. So usually with Meson you can just need to run Meson and specify the cross file, which is basically similar to the CMake cross file. We can see also this one, Meson target to chill fine. So this is also specifying the cross compilers for this platform, so which is the C cross compiler, C++, Objective-C, and some other useful tools. And if you need to specify some specific arguments for the C compiler or the linker, you have to modify this file. So unfortunately, with Meson, we have to patch this file if you need to add extra arguments, which is a bit annoying, but okay. And here the prefix is already specified, so you don't have to manually pass in the command line as an argument. So let's go back to the documentation. So when you use Meson, then you build instead with make, you build with Ninja. So well, the syntax is the same, so it's Ninja, and if you want to do the parallel build, -j and nproc to specify the number of processes, the parallel processes to use. Okay, yes, another useful thing to keep in mind if you want to write your own build script starting from an existing one, is that the dependencies can be either a runtime dependency or a build-only dependency. So the difference, this is only useful for the JLL package. Sorry. So if you want to build for the JLL package, a dependency that is specified as dependency, it will also be a dependency for the JLL package. For example, for this xorg xkbcomp library, this libxkb file was a runtime dependency, so this needs to be there when you want to run this library, when you want to call this library. But instead, this library, this xorg util macros, is only providing some header files that you basically don't need at runtime for calling the library on the Julia side. So for example, in this case, it's useful to specify this as a build dependency, because this will not be a dependency of the Julia file in the end. And this is useful because in this way you have fewer dependencies for your final JLL package. So continuing the documentation, you may need to modify some files within the wizard, and you can use Vim. I think actually Nano is available. Yes, so if you prefer, if you are a Nano user, at least you can use Nano if you don't want to use Vim. And here there is the list of some environment variables that are already defined in environment. So they are useful to to keep in mind. So you have CC, CXX, FC for the Fortran cross compiler, and OBJC for the Objective-C cross compiler, which is actually only useful when you target macOS. So you can also specify some other flags. And here there is a list of some other environment variables that are already defined in the environment. Yes, for example, there is the target environment variable, which holds the triplet. So this is, for example, often useful when we want to have a single build script for all the platforms. But some platforms has some slightly difference during the build system. This happens very often, for example, with Windows. So we need to specify some different steps for Windows, for example. And we can do this doing something like this. Target equal to, for example, for Windows, that will be being W. Then, so in the build script, we can do something like this, that we can add some conditionals to say I want to run these commands within the bash script only here, only for this platform. So you refer to the target environment variable. So nproc is a variable with the number of processes available, and bits is a variable with the number of bits for the target platform. So for example, in this case, we were trying to build for this platform, which has 64 bits. So also this one is sometimes useful to do some conditionals, because maybe, I don't know, you have to specify some special arguments, I don't know, or run some specific steps only for platforms that have 64 bits. And so this variable is very useful. So this refers always to the target platform. There is also approach family, which tells you the family of the processor, again for the platform, for the target platform. In this case, we get ARM. Then there are also DLxt, which is the extension of the dynamic library, of the shared library, and also xext, which in this case is empty, is the empty string, because for Windows, for Linux, macOS, and FreeBSD, basically, or the Unix-based systems, usually the executables don't have an extension, but Windows uses the .x extension. So only for Windows, this variable will be .x, including the dot. So again, these variables are useful when you want to do something different for each platform. And then there are some other variables to keep in mind sometimes. There is, for example, libdir, which is the directory where the library will be, the shared libraries will be installed. And this is important because it's different, again, between the Unix-based systems and Windows. So for all the Unix-based systems, libdir will be the prefix /lib. Instead, for Windows, it will be prefix /bin, because all the shared libraries have to go in the same directory as the executable. And the directory where the executables are instead is called bindir. So yes, it's the prefix. Remember, the prefix was workspace / destir. So bindir is the prefix / bin. Okay, so here in the documentation there are some other instructions how to, for example, use GCC on macOS and FreeBSD, how to install the license file. So the build system actually will try to automatically install the license file if it finds in the source directory some files with some meaningful names like license.txt, .md, some other extensions, or copyright.txt, .md, and whatever. But if it can't find any of these files, it won't install any license file, and the compilation will complain about this. So, for example, this happens if the license file has a different name, it doesn't have a standard name, one of these standard names. So what you can do is to run the command install license and pass as argument. So for example, here we could do install license, and this will be install the file called license to the directory where it is expected to be, which is this one. But actually in this case this will be automatically installed because it has an expected name. Then there are some other utilities provided in the environment. One is atomic patch, which is similar to patch with a standard patch, with the difference that it fails gracefully when a patch cannot be applied, because actually the standard patch messes up. I don't know if you can see here. Okay, maybe this is better. The standard patch function would mess up the file if it can't apply the patch. So instead we use this atomic patch, which simply doesn't fails but preserve the original file. There is also again the install license and update configure scripts. So sometimes configure scripts comes with helper scripts like this config.guess, config.sub. So sometimes they are not up to date, they need to be updated, and you can do using this update configure scripts, and it will automatically look for all these config.guess and config.sub. So you will know if you need to run this command, because running configure would fail while trying to call one of these scripts. For example, this happens when the scripts are very old. They don't know about the muzzle C library, or about the I think the 64 ARM platform. Probably this is also written in the documentation. Yes, yeah, for example, it's mentioned here. You will see that configure guess or configure sub, I don't remember, can't recognize this platform or the C library. So when you see an error on configure.guess or configure.sub, try running update configure scripts and then rerun configure. I think this is most of what I wanted to show. If you have some questions, by all means ask me. Also now maybe I will wait some minutes now to see if there are more questions, or on Slack, on Discourse, or whatever. I hope this was kind of useful for to have an idea how binary builder works. Okay, so there is future plans for binary builder. So if you go to the repository, there are some issues that are interesting. Let me try to make it a bit larger. Okay. So actually we would like to make the audit at the end. So when you build the library at the end, probably you've seen it will do some checks. So these checks are, for example, fix some paths, some dependency paths within the shared library, or to check that all the symbolic links in the tarball point to existing files within the tarballs. Otherwise you will get a tarball which is pointing to nowhere, with some files with some links that are pointing to nowhere. So we have some steps in the in this audit, but we would like to make it the audit smarter to find some more errors. There was an idea here that I can't find now. Let me see. Probably it's not labeled as audit. But yeah, make it smarter. There were some issues. Here it is. Okay, it was not part of the audit. So maybe something that will be interesting to do is to generate a DIG, like a tree of dependencies of each library, so that we know exactly which library depends on which. So the idea will be also to produce this DIG of the dependencies and to write it down in the library or in the tarball somewhere. This will be ideal because in some cases it would allow us to fix some errors that we have found when trying to loading libraries within Julia. But again, I think that Binary Builder is a very interesting tool. It's already working pretty well for the general use, so not specific to Julia. I really hope that developers outside of the Julia world will start using. Actually, we have a website to advertise Binary Builder. It's called BinaryBuilder.org. I think, yes, my colors are a bit odd. These are not the colors that are expected to be in the browser. So if you go here to the BinaryBuilder.org website, you will see some comments about what you can do with this tool, and this is more targeting the general audience, so not just developers. This is to explain to the external world what you can do using Binary Builder, which I think is very powerful. Again, the possibility of building for a lot of different platforms using just a single machine is very great. And this can just be a good way also to test your build system. So if you are a C++ developer and you want to make sure that your build system is going to work, I think that Binary Builder is a great way to test it, because it breaks some common assumptions, because as you have seen in the build environment, the libraries are not in the standard location like use lib or use local lib. They are in some very strange directories, which is slash workspace slash desdir slash lib. So having the possibility to check that the build system is going to work also on this very particular environment, it's a great way to check that your build system is reliable, is going to work on probably most of the machines. So even if you don't care about doing cross compilation or using this to provide the pre-built libraries, which is actually, I think it's a good way to it's a good use of Binary Builder to build the libraries for your users. But even if you're not going to use it, I think it's still a good way to test that the build system is reliable and can probably work on as many platforms as possible. Yes, you can see that we support lots of different operating systems, different CPUs, many languages. The wizard has the hints, which are sometimes very useful. Yes, you have cross-platform consistency because again you can build the same library executable for all the platforms in the same way, basically, using mostly also the same tools. Also experience, because so far we've built lots of binaries and we are improving on our errors. So we are trying to to get better and better and to make life easier for the users. And okay, there is a question a question about if we know someone using a binary builder outside of Julia. Unfortunately, no. But yeah, my hope is that in the long term, in the future, more people will be interested in using this tool, not for Julia, but just because it's a very nice tool to provide the libraries for the users. Yeah, again, there is really nothing specific to Julia in the end product that are the turtles. So the JLL package is something extra that we do for the Julia users, but it's not the main thing for the main way that you can use Binary Builder. Also, okay, here it's not working in this Ghost script, but if you do manage to build something, you just get the products, the turtles in a subdirectory called okay, this failed because it didn't work. So yes, it worked for one platform probably. Yes, and there is the turtle for x86, 64 Linux GNU, the turtle. So you can just run the script locally and produce the turtles locally, and yeah, it's very useful, I think. Yeah. Other questions? Well, if not, I will say that we can stop here. It's already 1 hour and a half going on. Okay, thanks for watching and thank you. Bye bye.